This is a very short video describing how our GChans work from the paper Parameter Prediction for Unseen Deep Architectures. So first we gonna install all the package all dependencies. So I already did that, and it's very easy and straightforward. And then we also load the CFAR10 test data just to evaluate our predicted parameters on those images. And now the most interesting part is that we load the GChan trained on CFAR10. So we have several pre-trained GChans available, and we just load one of those. And then we load some network. It can be actually arbitrary neural network, and we are gonna visualize it just to have a better idea what the network looks like, and then we're gonna predict all parameters for that network. So it should take just a few seconds, and as you can see right now, we visualize ResNet 50, and we already predicted all parameters for that model. So it took just half a second on the CPU to get all 23.5 million parameters. Now we can evaluate those parameters on CFAR10 test images. So it will take a while, but we can wait. Alright, so it's finished. As you can see, the accuracy of predicted parameters is 58%, which is pretty good, given that we are not doing any gradient updates on the network parameters, and our GChans have never observed such a big network and with such configuration of nodes and edges. So we can try other networks, and you can basically choose arbitrary network from Torch Vision. So we can pick any model from this list. For example, we can choose, say, ResNet 152, which is a very big model. So let's try this one, and it takes a while to visualize the graph, but the parameter prediction actually takes just 2 seconds on CPU in this case, because there are like 58 million parameters, so it's a bit more. And we can now evaluate the same way as ResNet 50, so it will take a few seconds. Alright, so the accuracy is a bit lower, but still much better than random. Random would be 10% on CFAR10. Alright, and okay, so it doesn't have to be ResNet, it can be any model. For example, we can try VGG 11, which is a smaller model, so we can evaluate it faster. And it also, as you can see, it doesn't have any skip connection, so it's a pretty simple model. And it should take fewer seconds to evaluate it. yeah, so it's done. The accuracy is quite low. So yeah, our JSONs do not always predict high accuracy, which would be too good. So here we can try basically any other model. We can create our model on the fly. We can choose any configuration we want, and we can still predict parameters. Oops. So I just need to create an instance here, and it must be evaluation mode, so that should be good. Yeah, so it's just a few nodes. The accuracy is a bit better than VGG, but still very low. So we can change anything in this network, and it will still predict parameters. For example, we can increase the number, we can add a bit more layers. Say, okay, let's try to add 2 layers, maybe. I'm removing average pooling because the images are very small, so we are not. We need to remove average pooling to process those images, and then I'm also adding padding, because again the images is very small, so we want to preserve the spatial resolution of features. So I think it's good, and so prediction is done. So prediction takes just less than a second. Again, the accuracy is about the same. We can add batch norm, for example. If we want, it's still the network will be the predicted parameters will be adjusted according to the architecture. Yeah, so you can see this green square is the batch norm that we added. We can evaluate again and get a bit better accuracy. So the same way we can play around with the network, and we can instantly get the parameters for that network and evaluate to get the accuracy.